Alright then guys, so today I'm rebuilding the upper spindle bearing housing. I've got a new set of replacement bearings. These are the original shielded EE10 bearings, imperial size. And then these are the new replacements with the sealed cover. And I believe the code is an R182RS. So they are the same size, internal and external diameter, but the thickness or depth is slightly more. So the cap may sit proud, but it's not having to seal for grease anymore, so it shouldn't be a problem. I've got the first bearing pressed in there, then there's this grease sleeve goes in, and then an inner sleeve, and then the next bearing will sit on top and get pressed in as well. Well, this is what victory looks like. Spent about an hour and a half last night battling this clock spring, trying to get it back into its hole. But now it's in there and it's doing what it should. There's another face cap goes on here with a locking pin to go on to then tension the spring. But that'll give the Quill a nice spring back. And it was all stiff, where now I've freed it up and I can use the Quill mechanism by hand. There is meant to be a lever that goes onto this bar, but it didn't come with the machine, so I'll have to fabricate one. But for now, I'm happy. The Quill moves. We've got spring back. Obviously, once the tension's done, it'll be a bit more sturdy. But that's great. It's coming together. Really happy with that. Alright then guys, so today I'm working on the Alfred Herbert vertical milling machine. I've been swapping out the grease nipples or Zerk fittings to quick fit connections, 4mm quick fit connections for a CNC type oil pump. So I can just do one pull of the lever and it'll oil all of the points that need oil, you know. So it's going to make it so much more easy to use. And I've managed to get one of these small grub screws removed and a bolt popped through the knee to fit one of the manifolds onto the knee to run to all the different points on the knee and the table. And then there'll be a point, a hose going from here up to the headstock, and that's where I'll be putting another manifold to run those 4 points there as well. Right then, in those past couple of videos there, I've just been fitting the 4mm tubing and quick connect push fit fittings onto adjustable flow rate manifolds, which are these blocks here and here, so that I can control the flow of oil to each individual point separately to adjust, because some have more back pressure than others will, and obviously you don't want to just be squirting loads out somewhere that there's not much back pressure when you need it to purge through somewhere where there is. Got most of the tubes fitted with the sheathing material that comes with it, with this kit that I've got, but there isn't quite enough to do all the tubes, so I'm probably just going to have to try and source some more. Not sure where I'll find it, but we'll see. Hopefully I'll be able to get some found, but for now it's looking good. It's going to be a lot easier than having to go around with an oil gun and a grease gun to get to all the different points. It's all now hooked up to one lever, and that has a reservoir inside of it and a little fill level indicator there, so you can see how much oil you've got left as well. Same as what I've used on the lathe. You can see it's set up here. It's running to the Myford. So it's going to be nice having both machines with the same oil system. So nice and simple, because it's easy to overlook oil points and forget about them. I'm happy to just have a lever that I pull and I know everywhere's getting oil. Alright then guys, this is just a quick video to show the Z-axis up and down vertical travel movement of the knee on the Alfred Herbert milling machine, without any assistance from the ram that I'm about to fit, just as a comparison. So this is how it moves by hand at the moment. Obviously going down it is no bother, the weight helps it go down, but coming up it takes quite a bit of force to get the table up, so it's manageable, but it's not as easy as I would like it. So I'm now going to install this ram and do a quick video to show the difference, as I can barely turn this with one hand at the moment. So now with the ram installed, I'm going to see the difference in the vertical travel, as how hard it is to move up and down. So that's considerably easier going down, as the ram takes the weight of the table. And then going up, still fairly difficult one-handed, but it does take just enough of the weight to make it that bit easier to manoeuvre. Going down is an absolute breeze, but up is still a bit resistance, but I'm happy enough with how it is there. I've got the original switch in place, just got the little display from the spindle motor VFD just sat there at the moment. And yeah, got this inverter set up all in the cabinet, wired in. And now I'm gonna see if it I'm gonna put the power on, see everything working, test the power feed, which is the first time I've used it since I've got it, you know, since it was a 3-phase setup from originally. So yeah, electrics are all on there from the main isolator switch, which is switching on both the inverters. Now I can engage the spindle motor forwards or reverse with this longer lever, and then the shorter lever is what will tell the power feed motor to go forwards or reverse or left or right for the table, you know. So when the spindle motor is engaged, that will switch on the power feed box, and as soon as you turn the spindle motor off, it switches off the power feed as well. So yeah, let's see her in action. Power on, inverter creeping up to the volt, to the frequency. So that's the motor on, got the power feed working. And I can change the direction of that lever, so it stops, ramps down, and then restarts in the opposite direction. And all that can be adjusted through the VFD's programming, so I can speed it up or slow it down, add braking. So pretty happy with that. Alright guys, I'm just going to do another little video showing how to operate it with the new electric setup, new switch configuration. So that would be forwards or reverse for the main spindle motor, and left or right for the power feed motor, engaged when the spindle motor is on. So you can hear the motor starting up there, and then you engage the worm gear drive shaft from the power feed gearbox to drive the lead screw of the table. Now this original engagement lever here corresponds with a T-slot along the face where you can put a stop that will automatically push this lever and disengage the power feed when you hit a certain point. So if you wanted to do a set length, you can leave it to do that by itself, and it won't just keep running past itself and knock the gears. It will actually disengage the drive, you know, just like that. Obviously to reverse it the other way you would have to flip the lever. It doesn't do that itself, but for now that's a good setup, I would have thought, for me. But yeah, I'm pretty happy with it. It's working. Hi guys, so today I've been working on getting the main spindle motor hooked up. So now the mill is actually up and running. Finally, after all this work, the machine now runs off 240. Both motors are powered by VFD inverters, and it will run in my garage as opposed to a huge workshop or needing a rotary phase converter. So I'm pretty happy. Pull the lever down, Spindle motor engages on and we have movement. Flick the power feed on. Emergency stop works a treat. Turn that off. And then you've got to switch it back to the off position to restart it. So it won't just restart by itself after you've hit the emergency stop. Got the display in its own little enclosure with the spindle display as well.